So we got an interesting little stats section here. So they're starting off, they're giving us all this data. So let's read it. In baseball, the on-base percentage for a team represents the percentage of time that a player safely reaches the base. The data given in Table 6 represent the number of runs scored, Y, and the on-base percentage, X, for teams in the National League during the 2008 baseball season. So there's our data. So A, draw a scatter diagram of the data, treating on-base percentage as the independent variable, meaning the X, which you see the points we have up there as well. And then, so they want us to do it by hand and then with a graphing utility. We're just going to do it with a graphing utility. And actually, I've already done that. So here is our scatter plot. And so then they ask us to say what happens as Y or as X goes up. What are the variables? Let's side by side it. So they say what happens to the runs scored as the on-base percentage increases. Well, so it looks like it goes up, right? As the X variable goes up, the Y variable goes up. So X is the on-base percentage. As the on-base percentage goes up, the runs scored also goes up. And that makes sense, for sure. So here's some other ways to look at scatter plots. Determine whether the relationship between the two variables is linear or non-linear. So that's just like, does the pattern follow a line? So you see in our baseball example, you could say that the dots follow a line pattern. It's not necessarily about how close they are to the line, just if the pattern is linear. And so you see the idea is like if you draw a line through the dots, A definitely seems like it's linear. Whereas B, you can see that parabola pattern that the dots are following. And same with this one, you see this like cubic pattern that they're following. And this like half parabola that they're following. So these are not linear because the dots just don't follow that line pattern. Whereas the first one is. So it's not about, they're not all on the line. They just all follow that line pattern. So for the next question, we're going back to this data. So they say, A, just select any 2 points and find the equation of the line between those 2 points. Then graph the line on the scatter diagram. Okay. So let's do that. Let's just pick any of the 2 points. Let's do that one and that one. For no reason, I just picked them. So the difference in X value and Y values, 720 minus 799, over the difference in X values, 32.7 minus 33.2. And I'll just go ahead and type that into the calculator here. So 720 minus 799, close the parentheses so we can divide 32.7 minus 33.2. Oh, perfect. Dang, okay. 158. 158 is the slope. Nice. So that's what they asked for in A, right? Select 2 points. Oh, find the equation. And then graph the equation. So what's the equation then? So the slope is 150. We'll use point slope form. So the slope times X minus one of the X values. I'll do 32.7 equals Y minus the Y value, the corresponding Y value, 720. So let's graph it. We can just really do it from right here. So X minus 32.7. And then I'm just going to add over the 720. And so you can see the 2 points that line goes through. Those are just the 2 points we picked. So that particular line does not show the pattern very well, right? So that's not what they're saying. But I think on the next problem, they do want us to. So this is a thing calculators can find. I don't know the perfect way to do it on Desmos, but I can show you just kind of how to do it with equations. So let's find the best fit line. So when we find the best fit line, we need, just for any line, we need a slope and we need a point. So the point is the most easy one to understand. So let's define it. So the x coordinate of the point is just going to be the average of our x coordinates. What is it? x1? Yeah. And then the y coordinate of the point, I'll call it y0, is going to be the average of the y coordinates. So that's pretty straightforward. Maybe I'll put that point on the graph. So x0, comma, whoops, comma, y0. So that's the point. We can see that's the point that's in the middle of all those points. So our line is going to go through that. Now we just need the slope. And so there's equations for that. The equation is straightforward. We do need the calculator to calculate a lot. So we're going to have the correlation coefficient. So where do you find that? Under statistics? Or distributions? No, statistics, the same place where this is. So you go correlation. So it takes in two different values. So we're going to do the correlation between x1 and y1. And that's a number, 0.75. So that number does tell you, it's not the slope yet, but that tells you how correlated they are. The closer to 1, if they were 1, they'd be perfectly correlated. If it was 0, there'd be no correlation. So here, 0.75, it's a pretty decent correlation. So now to get the slope, you just remember that it's the change in y over change in x. So in this case, that means we're going to do the standard deviation of y divided by the standard deviation of x. And that's our slope, 40. So let's see. So now to write the equation of the line, we have everything defined. We've got to do the slope times x minus x0, close, plus y0. And we can definitely see that that's pretty good. I think it'll be easier to see if we get rid of the red line. That is the best fit line for those points. That is the general pattern that these lines follow. So one test you can see to see if it's good is the same number of points should be above the line as below the line, or at least roughly. So let's see. So below the line, there's 1, 2, 3, 4, 5, 6, 7. Above the line, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think that makes sense because above the line, there's these two that are closer. But yeah, that's going to be the best fit line of that data. And you can see how it does go roughly through those points. So what else? They want us to graph it, interpret the slope. So interpret the slope on average. What did we find the slope was? 40? We have it here, don't we? 40. So on average, when your on base percentage goes up by 1%, your runs scored goes up by 40. That's what that says. Is your y variable is the runs scored. The x variable is the on base percentage. And what the slope is how much the y variable increases when the x variable increases by 1. So how much the runs scored increases when the on base percentage increases by 1. Now use the line of best fit to predict the number of runs a team will score if their on base percentage is 34.1. So that means we don't need to look at the points, we need to look at the line, and we need to say that when the percentage is 34.1, we passed it, that's right there. How many runs do we expect them to score? About 775.432. So, of course, you see the one team that's close to that scored more than that, but that's not what they're asking. They're asking us to use the line to predict it. And so that would be, we'd predict that they would score about 775 runs. And that's it for this section. Quick little scatter plots, quick little statistics section. So that's like we talked about up here, is that these are like linear models. So they're just models, they're not perfect, but they can still be useful to predict things and to generalize patterns, as long as we understand that they're not perfect and they are just models.